Okay, so our picture is on nuclear chemistry. Enjoy it. That's it.
Yeah.
This video is funny in many ways. If you find learning very unnecessary, you're an idiot. This video contains high educational values with two idiots trying to teach. So shut up and listen to this one. Enjoy!
I'm Christopher,
And I'm Lucas.
and this is Nuclear Chemistry.
Aluminum radiation is when two protons and two neutrons leave the atom, forming a helium atom. Alpha radiation is the weakest type of radiation and can melt through paper. Beta radiation is when an electron leaving the atom, thus giving it a negative charge. Beta radiation penetration power is strong enough to go through paper but not through aluminum. Gamma radiation is when pure energy leaves the atom. It has the strongest type of radiation, even going through lead and concrete. Fission versus fusion. Fission is when an atom divides into smaller atoms. Fission is used to make atomic bombs. Fusion is when two smaller atoms combine to make a bigger atom. Fusion is used to make hydrogen bombs. Alpha, beta, and gamma radiation. Alpha decay, for example, in an equation, uranium-238 going through alpha decay turns into thorium-234. Beta decay, for example, potassium-40 going through beta decay turns into potassium-40. And gamma decay is just pure energy leaving the atom, just not changing the atom.
Alright guys, I'm Lucas. It's my turn to making this video. I'll be telling you about how nuclear fission, nuclear fusion, and nuclear thorium reactors will work. Alright, we're starting off with this fission. Fission starts off with a neutron hitting uranium-235, which that neutron, which when it hits it, creates uranium-236, which then uranium-236 splits into fast-moving ladder elements. Let's say, and it causes a large amount of energy. But it's very insufficient. There's lots of radiation, like for example, in Chernobyl, that radiation is going to last for at least 3,000 years. Because it releases so much radiation and it lasts for a long period of time. But it is very insufficient, but it does create a large amount of energy than regular other coal, oil, and wind turbines and some panels will create as much energy. Alright, nuclear fission. Hydrogen atoms come together to form helium atoms, and then neutrons and then releases a vast amount of energy, which we still haven't made a nuclear fusion reactor because it's clearly unstable. It releases a large amount of energy, and that controls energy, which then this fusion is used in hydrogen bombs, which release a large amount of energy, more than a fission bomb, such as Hiroshima and Nagasaki. Those are fission bombs, and a fusion bomb is a hydrogen bomb, which creates a large amount of energy, and it has a larger, more powerful explosion than fission. Alright, let's see, this is how a thorium reactor will work. It's called a lifter. Look at fluoride thorium reactor. Let's see. And you start with fluoride. You use fluoride. You start with fluoride salt in this reactor. It will be heated up so much that it will melt. And you dissolve thorium fluoride in this liquid salt, which then thorium-232 absorbs a neutron and turns it into uranium-233. And the uranium-233 creates fission and produces the heat plus more neutrons. So this thing is a lot cheaper than fusion and fission because uranium is a very rare element. We're basically using platinum as an energy source, so that's how rare uranium is. And so thorium, you can find it anywhere. It's the cheapest, most sufficient energy source in the world. But we still haven't made a thorium reactor. And so this is, let's see how this is. A thorium reactor will create less radioactive activity than a fission and fusion. Fission creates the most radiation and lasts for a long period of time. And I'm not sure about fusion, haven't really started, but the thorium reactor will release less radioactivity than a fission uranium reactor. And this reactor will last for a very short period of time. Let's say there's a nuclear meltdown, and the meltdown radioactive activity lasts for 1,000 years. We have a meltdown with a thorium reactor. It will only last at least 20 to 100 years. The thorium reactor will release more energy than the fusion. I think they're the same, but I'm sure. The thorium reactor will release a lot more energy than the fission reactor, which uses uranium-238. And so this lifter, liquid fluoride thorium reactor, is very sufficient when it comes to energy. You get more energy out of it. I think this will power at least Washington DC and New York City. The thorium reactor will last so long and be so sufficient that we can use it for space travel, eventually use it for space travel, local travel, or air travel. This is very sufficient. For example, there's a new car that's being made, hasn't come out yet. It runs on thorium, and the estimated time for this refueling car that's using thorium will last for at least 136 years. It's very sufficient, it's very high quality, very little radiation. And this is a picture of thorium. As you can see, this right here, there's no marble, could last you, I believe it lasts you a whole lifetime. Because to power the whole world with thorium, you'll need 5,000 tons of thorium. And you can power the whole world for a year with 5,000 tons of thorium. And these are examples of thorium, how it would look like. It's very sufficient. So you need a small amount of thorium just to last a whole year for the whole world. And each mine at least produces 5 tons or more. And there are at least 30 to 40, 50 mines either mining for coal, or gold, platinum, silver, or copper. Those mines, you'll get more thorium than you will get platinum. It's really, really good. Very more sufficient than any other energy source in the world, and this can last for millions of years. Here's some more examples of how it would look like. I believe this crystallized solid, I believe it's thorium, and this liquid is one that's melted, or uranium-233, I mean. And under here, the bottom, and I believe it's the equation. Well, that's the end of this video. I really hope you enjoyed it. I'm sorry we weren't very informative, but we did our best for this video within a short period of time and get as much information as possible. I'll see y'all later. Have a great day.